All right, so we're continuing today's seventh grade, Monday, May 18, with scientific notation, where we left off from last week. Our first set of directions here tell us to write the number in scientific notation. So we're given a number, and it's our job to put it in scientific notation. So let's look at a few examples. Well, let's first of all remember our rules from scientific notation. Hopefully you paused and wrote down those three things that we talked about on Thursday, the 14th. Remember that the first rule of scientific notation is that it has to be written as a multiplication problem. Okay? Also remember that the first number in the problem, considered the factor, has to be at least 1 but less than 10. So it can be 1, but it has to be less than 10. Now I'm looking at my digits 4 and 2. That makes 42. The only way that I'm going to get a number that's at least 1 but less than 10 is to make that 4.2. Okay? Now I'm thinking, now what would I have to do to the decimal to end up with 4,200,000? Well, if I'm putting my decimal right here, okay, and it needs to come all the way out to here, I'm moving it once, twice, 3, 4, 5, 6 places. That means that it's 4.2 times 10 to the power of 6. And it's a positive 6 because I'm moving it out 6 places to the right. Let's look at this next one, 600,000. Well, I can see that my base number here is just 6. And that can work just by itself because 6 is at least 1, but it's less than 10. Now, if I'm going to put the decimal right here, because that's where it would be in 6, what would I be doing to get it all the way down to here? Well, I'd be moving it to the right, so I know it's going to be a positive exponent. How many places? 1, 2, 3, 4, 5. I'm going to have 6 times 10 to the power of 5. 0.007, 7 thousandths. Okay? I can see that my base number is going to be 7. All right? But if it's 7, technically my decimal would be there. Well, but the decimal in the number is here. So I'm actually going to be moving it to the left, which means it's going to be a negative exponent. 1, 2, 3 places to the left. That's going to be times 10 to the power of negative 3. All right? Let's go to the next one. 0.038. Well, I can see 38 there. That's going to be kind of my number, but my number has to be at least 1 or less than 10. So I'm going to have to use 3.8. Of course, it's going to be a multiplication problem. Of course, it's going to be a base 10 problem. And if it's 3.8, I'm going to envision the decimal right there. But the decimal was here originally. So I'm moving it to the left 1, 2 places, which means that my exponent needs to be a negative 2. 0.0000808. I see my 808 here, okay? But I need to have a factor that is at least 1, but less than 10. So I'm going to have to go with 8.08. If I put the decimal anywhere else, it's either going to be too small or too big. So I'm envisioning my decimal right there at 8.08. But in my original number, the decimal is here. So I'm moving it to the left. So once again, it's going to be a negative exponent. 1, 2, 3, 4, 5. I'm moving it 5 places to the left. 8.08, 8 8/800ths. Times 10 to the power of negative 5. 29 billion, 10 million. I get 2,901. The only way I'm going to get a number that's at least 1 but less than 10 is to have 2.901. Okay? So my decimal would actually be there. And I needed it to move all the way over here. So I'm going to be moving it to the right. So I know it's going to be a positive exponent, but how many places am I moving it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm moving it 10 places to the right. 2.901 times 10 to the power of 10. That's the first part of your assignment. The second part of your assignment tells you to multiply. Write your answer in scientific notation. All right, well, so when I look at this first one, 6 times 10 to the power of 6 times 4 times 10 to the power of 8, I can do what I know, like terms, 6 times 4. Well, 6 times 4 is 24. And 10 to the power of 6 times 10 to the power of 8, same base number, so I can just add the exponents. 6 plus 8 is 14. 10 to the power of 14. But remember what scientific notation is. Scientific notation is a multiplication problem, base 10 exponent, but the factor has to be at least 1 but less than 10. Okay? So 24 is too big. So I'm thinking, well, if the decimal is right there in 24, if I take this decimal and move it one place back, I'm actually going to end up with 2.4. And that number would work because it's at least 1, but it's less than 10. However, if I move the decimal, that's going to change my exponent. Because at 24, they told me to move it to the right 14 times. But now I've taken it and moving it to the left once to make it 2.4. Well then, since I backed it up once to end up with the same number, instead of moving it 14 times, I'm now going to have to move my decimal 15 times to the right to get the same number. And that is in scientific notation. Let's look at another one. 7 times 10 to the power of negative 2 times 8 times 10 to the power of negative 4. Well, once again, I'm going to start with 7 times 8. I know that 7 times 8 is 56. I have two negative exponents, base number 10, so I can just add the exponents. Negative 2 plus negative 4 is negative 6. So this is going to become times 10 to the power of negative 6. The problem is that this is not in scientific notation because this number 56 is bigger than 10. Remember that to be in scientific notation, this number that we refer to as the factor has to be at least 1, but less than 10. All right? So I'm thinking, well, what I would have to do is I would have to put that decimal and insert it right there and make the new number 5.6 because 5.6 is at least 1, but less than 10. But this told me at 56 that since it's a negative exponent, I had to move it to the left 6 times. Well, the decimal was right there in 56, and I've already moved it to the left 1 time to make it in scientific notation, 5.6. Since I've already moved it to the left 1 time, there's only 5 more times to move it. So instead of a negative 6, this is going to become times 10 to the power of negative 5. All right? Now, let's look at this third example. Sometimes there's going to be decimals. 2.8 times 3. You might want to just punch that into your calculator. But if you do 2.8 times 3, that's going to tell you that that equals 8.4. I like problems like this because I have a number that's going to work. I don't have to change this number. This number is at least 1, but it is less than 10. So I don't have to change 8.4. So now I just figure out, well, what's my base 10 number going to be? They're both base 10, same base number. I'm just going to add 7 plus negative 3. Well, 7 plus negative 3 is 4. So this is 8.4 times 10 to the power of 4. Some of them you're going to have to change, like in examples 1 and 2. Sometimes it's going to be straightforward and it's going to give you a nice number right away. All right? Have a great time, 7th grade. Talk to you later. Bye.